for my, I'm not recording you, it's me, it's facing towards me. All right, so we're going to talk about classification of matter. So we know what matter is, we're going to do a slight recap on that, and then we're going to talk about how we separate these categories, okay, and what they mean. Okay, this is not on your quiz tomorrow, okay, this is new information, okay, just so we're clear on that. All right, so recap, what is matter, okay, this should be locked in, okay, anything that has mass and volume. Okay. Now with matter in this class, we are going to break it down into two separate categories, okay? So we have our pure substances, which can be defined as elements and compounds / molecules. Now I will mention that compounds and molecules do technically have a different definition. They are slightly different. But again, for right now, compounds and molecules, when talking about categorizing matter, we're going to keep as the same, okay? And then we also have our mixtures, okay? And these are a combination of two or more substances in which each substance is actually keeping its own set of properties. And these are called homogeneous or homogeneous, however you'd like to pronounce it. I usually say homogeneous, okay? And heterogeneous, okay? Those are our two subcategories there. Am I okay to move forward? Some people are writing. Okay. All right, so let's talk about breaking down pure substances first. So we have those two categories of pure substances. Let's start on this side with elements. So as you can see, next to element, I just listed out some random elements from your periodic table. I put Cl, I put CO, okay, chlorine, carbon, oxygen, I put etc., and then I put periodic table. Okay, these are going to be elements that are on your periodic table, and they're in their simplest form of matter, and they keep their own properties. Another way that you might see this is like this, with a little 2 subscript, okay? This is allowed with elements. These are just two of the same element bonded together, okay? So this is also considered element, and that's okay. If you want to look down at our particle diagrams here, I know that yours aren't in color. In the future, on any sort of test, quiz, practice, we're going to try to make sure it's as big as possible and that you can kind of see the differences between particle diagrams so that you don't have to focus on the color per se. So when we're looking at the elements here, you can see that all of these are the same, and that's kind of what we're trying to get at, okay? They are all the same element. I'll give you a second to keep writing that. Moving on to compounds and molecules. The examples that I put up there are H2O, water, okay, and NaCl, which is salt, or your common table salt, okay? So a compound or a molecule is going to be our two or more different atoms that are chemically bonded. So something new is happening when they're put together, okay? They have new properties. So putting hydrogen and oxygen together is making a new substance of water, okay? If you want to look at our particle diagrams here, okay, you can kind of see that we kind of have a bigger particle with two smaller ones, okay, showing that bonding of two different atoms. Is that clear? Does that make sense? Some of you are not awake yet. Some nodding would be good. Okay, cool. All right. I'm going to move forward then. Okay. So when we're talking about our qualities between elements within molecules, there's two important things that we're going to talk about here. We're going to get into more detail with this in later units, but right now we just want it to be in your head so that if you see it, you understand what it is. So we're talking about subscripts. Okay, subscripts are the little tiny number that's written below, okay? So these are written after an element symbol to indicate how many of that element is present. So, for example, looking at H2O over here, okay, we see that H2, which symbolizes 2 H's. So there's 2 hydrogens in H2O. That's what the subscript means there. Now, it distributes to all elements when written after a parentheses. So what does that mean? So if we want to look down here, okay, you'll see that this molecule here is written in parentheses. It has its own, it's SO4, okay? And then we have that subscript 2 after it. So that 2 is indicating that there's 2 of that molecule in the parentheses, okay? Something else to note, when they're in parentheses, which I'll get to in just a second when we talk about coefficient, it'll make sense. You can see, sorry, I kind of wrote over it, but you can see it on your paper. This SO4 here has an O4 at the end. Okay, this subscript that we're using here is actually going to multiply in. So when you read this, okay, it actually means, okay, that there's 2S, okay, but we're also going to multiply this 2 by 4 here, which means that we have 8O. Does that make sense? Just simple multiplication there. Now we're going to see this something very similar when it comes to coefficients. So our coefficients are our numbers that are written before the element or the molecule, and this is going to distribute to all the elements within that molecule. So if I wanted to write 4H2O here, sorry, this would mean here that I have 4H, okay, oh, I'm so sorry, 8, oh my gosh, words, yes, 8H, math is hard, okay, and 4O. Because I am using that coefficient to distribute here. If I have a subscript, I'm multiplying my coefficient by my subscript, which is getting me my 8H, and then my 4 by my O is giving me 4 oxygens. Good? Yes? Okay. If it's confusing, please let me know. I can try to re-explain it. Are we all okay? Okay, cool. I know my writing on the board is kind of awful sometimes. I'm working on it. All right. So let's move on to breaking down mixtures. So we talked about our pure substances. Now we're going to talk about mixtures. So our first one over here on the left is our homogeneous again, however you want to pronounce it. Okay. This is most of the time or sometimes known as a solution, which we're going to talk about a lot in this class. There's a whole unit on solutions, okay? This is a mixture that has parts that are uniformly mixed. And I will show you a particle diagram on the next page that'll help you to visualize this a little bit better. But some examples of this would be air, because air is not only just oxygen, okay? There's multiple elements in it, nitrogen, CO2, okay, oxygen, okay? It's uniformly mixed. It would be bad if you were breathing in air and there was just random pockets of carbon dioxide that you're just breathing in, okay? It is uniformly mixed. Kool-Aid, good example here. If you add a Kool-Aid packet to water and you mix it really, really, really well, okay, those particles within the Kool-Aid are uniformly mixed within that water. Okay, if you have chunks of Kool-Aid mix at the top or whatever, that's not necessarily uniformly mixed, but a really well mixed mixture of Kool-Aid would be homogeneous. Blood is another good example. Salt water, similar to Kool-Aid, okay, if you mix the salt really, really well into the water. And then an example of a metal like brass. Okay, sometimes people can get confused and be like, well, that's a compound because we see the copper and the zinc here. It is a uniformly mixed substance of both copper and zinc. Okay, so when you mix those together, it's making something new, if that makes sense, okay? Moving on to heterogeneous, okay? This is our mixture in which our parts are not uniformly mixed. So many times you can see or visualize those different parts when you're looking at a mixture like this. So some great examples would be trail mix. Okay, if you're looking at trail mix, you could individually pick out each piece a lot of the time. Peanuts, chocolate, raisins, whatever, berries that you're picking out of the trail mix, okay? Not uniformly mixed, okay? Sand mixed with water, okay? Ice cubes in water or in soda or whatever. You could actually take the ice cubes out of that, right? You could stick your hand in or a spoon and scoop out the ice cubes out of a liquid, right? And then cookies is another great example, help you visualize, okay? Cookies that have some sort of topping in them that you could individually pick apart, okay, and or all the components of that. Do these make sense? Some people might have heard of these before. So here you don't have this, but it'll be in Google Classroom for you. I wanted to show you kind of the difference in the particle diagrams for each of these mixtures here. So if you want to look at heterogeneous here, it's kind of hard to see probably for some of you, but there are some really dark particles and then some really light particles here. And it's showing you that these are not distributed uniformly, okay? So they're separated, okay, into two sections. There's some dark here, some light here, and then just a random dark one down here. For a homogeneous mixture, we can kind of see that it's dark, light, okay? So these are actually distributed uniformly. All right, this should be on the back of your notes, I believe, okay? So this is just your classification of matter flow chart. So if you are sometimes confused and you're studying or looking over something, you can refer to this chart. I also have one in more detail at the end of this PowerPoint that you can look at in Google Classroom that gives you more examples and kind of more of a question thought process when it comes to identifying matter. In this instance, it's just showing you in simple terms the pure substances and the mixtures, okay? Talking a little bit about each one, and then separating into our elements and our compounds, our homogeneous and heterogeneous. Before we kind of do an activity together, does anybody have any questions about any of these? No? All right. So on the next few slides, I have examples, okay? I am gonna pull sticks for somebody to tell me what each example is. You're going to tell me, is it a pure substance or is it a mixture? And then its classification. So if it is a pure substance, tell me if it's an element or a compound. If it's a mixture, tell me if it's homogeneous or heterogeneous, and then how do you know? I'm going to give you guys 30 seconds to a minute in each slide to talk to the people next to you and discuss, so that when I do pull your stick, you do have an idea and you're not just being cold called. Sound good? All right. First one, soup. Go ahead and talk to each other. Try to figure this out. Pure substance or mixture, classification, and how do you know? Some of these might be easier than others. There's some tricky ones. Second, all right. I'm going to take the silence as we got it. Okay. Tyler.
Heterogeneous mixture.
Okay. How do you know?
Because like the soup, it's got the stuff in it, but like it's not mixed in it.
What? Okay. I get where you're trying to get at. So when you're looking at the components of soup or this soup, could you individually pick out each piece if you wanted to? I'm sure that you've done that before. You've had soup that you're like, ew, I don't want to eat tomatoes or carrots or whatever, and you're like picking it out. Okay, yes. So heterogeneous mixture, okay? You know that because it's not uniformly mixed. Nice work. All good? No questions? All right. Water, H2O, not referring to the duck, the water. Okay, go. If it helps you out, when in chemistry, when we're going to be referring to water, we're going to be referring to our distilled or pure water. Okay, so not mineral water, not with stuff mixed in it. Okay. Are we good? Yeah. All right. We got Sophie.
It's pure substance,
Okay.
like specifically a compound.
Okay. How do you know?
Well, it's one of the examples on the flow chart.
It sure is.
And then just like a homogeneous mixture, because it's all the same. And it's like uniform.
So I get where you're getting at, okay, but you kind of combined your two terms. Okay, so yes, you were right with it is a compound, okay. Pure substance, it is a compound, but don't mix homogeneous in with that because that would be separate. I know what you're getting at. You were trying to get at it's two atoms put together, right? Okay. Can you separate H2O physically? Or is it chemically? Chemically? Yes. If you wanted to separate the individual atoms, you would need to do a chemical change to be able to do that as well, which is also how you know it's going to be a pure substance. Okay? Any questions? We good? That one was kind of an easier one. I kind of gave you that one. All right. Air. Go ahead. Discuss for a second. You guys talked a lot less than first hour. You guys either really got it or you're not awake. It's probably the really got it. We good to go? All right. Audrey.
It's a mixture and it's homogeneous.
Okay. How do you know?
There's a ton of different chemicals mixed in it.
What did you say? One more time.
There's different elements mixed in it.
Yeah, different elements are mixed in it. Is it uniform or not uniformly mixed? Huh?
Is it?
It is uniformly mixed. So that's how you would also know it's homogeneous. Okay? Remembering that our mixtures, if you really want a good way to think about it, our homogeneous is our uniformly mixed particles and our heterogeneous is our non-uniformly mixed. Nice. Cookies. Go ahead. Jackson.
It's a mixture and it's heterogeneous.
Okay, how do you know?
Because you can personally take out the chocolate chips out of the cookie.
You could. So not uniformly mixed. Yeah, nice. Good work. Some of these I gave to you, so. Awesome. All right, Neon. Go ahead. Discuss. All right. Kyle.
It's a pure substance and it's homogeneous.
So if it's a pure substance, that is correct. But the classification that we need is if it's an element or if it's a compound. So is it element or compound? Homogeneous would be a mixture.
It's an element.
It is an element. How do you know that? It's easier than you think. Don't overthink it.
Neon.
It is neon. It's right on your periodic table, right? Okay, yeah, it's just an element by itself, okay? Fun fact though, when you do look at a neon sign, okay, neon is what's giving that, that fluorescence. But the color change is actually something else in a neon sign, because neon by itself is colorless. So, just a fun fact there. But yes, neon on its own, or any element that I give you just straight up from the periodic table, is a pure substance and an element. Nice. All right, so there's going to be one more, and this one's kind of difficult-ish, okay? So definitely discuss it and make sure you have a good justification for it, okay? Gasoline. Go.
I think we're up to
I'm thinking like a pure substance. I don't know, like I'm just thinking like it's coming to me.
We're definitely going to talk about it, so if you're a little thrown right now, that's okay. Just be ready to justify why you think it if I call on you. Are we good? Who's the lucky person? Blessings.
A pure substance compound.
Why do you say that?
I don't know, I just I don't have a reason, I just
Okay,
Yeah.
okay. Is there an image that's making you think it's a yeah.
picture.
Okay. This is what's making you think it's a compound?
Yeah.
If you told me that, if I gave you this, like both of these, and had you tell me that, I would take that as an answer. Did somebody else have something different? Theo.
Well, I kind of see the same thing. I just wanted to help a little bit.
Okay.
So the only thing in there is one molecule. It's just multiple of like that one molecule.
Right.
Which is the gasoline itself. And so it can't be a mixture because there's nothing else in there other than gasoline.
Fair. I would take that as an answer as well. Anybody else have anything different? Did anybody say mixture? No one said mixture? Okay. Okay. So let me explain this one a little bit. So, when we are looking down here at the compound that I gave you, this is the compound for octane, which is commonly found in gasoline. So yes, if I gave you this, you looked at this and said, I'm looking at this compound here, it's a pure substance because it's a compound and it's just octane on its own, I would take that. Congrats. But now when we think about when you go and actually pump gas with gasoline, okay, gasoline that you're pumping into your car does have a few other weird things mixed within it. So it's not just octane on its own. So I would take a homogeneous mixture if you were looking at this and said the gasoline that you're pumping into your vehicle is a homogeneous mixture because it's multiple things mixed within it, right? Uniformly dispersed. Does this make sense? Yes. Okay. Kind of a tricky one, right? I would have taken both of those answers. Okay. Awesome. Good work. Wow, we still have a good amount of time. All right. This is not on your note sheet, but it will be in Google Classroom if you want to look at it. I really like this one. I like that it asks you some questions up here, kind of like, can the matter be separated by physical means? If it's yes, it's a mixture. If it's no, it's a pure substance. So it kind of gets your thought process going a little bit more when you look at this one. It also gives you a little bit more detail when it comes down to the categories within, or the subcategories within mixture and pure substance. So it tells you more about a solution here, okay? It tells you about the different elements bonded together, okay? It tells you that for an element, it's only one element, okay? One term that I didn't mention that we'll talk about a little bit more, it's on this flowchart here. I don't think it was within your notes, but an alloy. So the term alloy is one or more solids that are dissolved in another solid. So before, when we were, remember when we did the lab with the screws that we were using water displacement for, and we were finding the density of those? Do you remember doing that? Yes? Okay. We had some weird density readings because Ms. Simpson and I believe that those screws, the nuts or whatever as well with them, may have been some sort of metal alloy. It may not have been a pure metal on its own. So the density was a little bit all over the place because of that. Does that make sense? It's multiple solids that were mixed together? Okay. We'll talk more about that at a later time, but that's good to know as well. Cool. All right. So I don't have a bunch of copies of these right now. So I'll pass out what I have and then I'll make some more copies during the last 10 minutes. So if you want to turn and just chat for a second while I make some copies, I'm fine with that. Where is her copies?
Which company?